Hi, welcome back. Direct current motors represent the easiest way to add movement to your projects. But easy does not mean less capable. A direct current or DC motor can be a very cost-effective and flexible solution for all sorts of projects. Robots, cars, boats, toy helicopters, home automation, and many more. In this lecture, I'll show you how to use a DC motor through a series of demos. All involve two geared DC motors. Why use one when you can use two, right? And a motor breakout circuit. I'll explain what these are in a minute. Here's what we're going to build in this lecture. First, we'll just hook the motors to the Arduino via the motor breakout board and make them spin in a single direction. Second, we'll get the motor spinning forwards and backwards using a potentiometer as a controller. Third, we'll use an ultrasonic sensor to get the motors to spin faster or slower depending on the distance between the sensor and an object in front of it. In this first experiment, we'll build a simple circuit that controls two geared DC motors from a toy tank that I stole from my kids, which they originally stole from me. Even though you could connect the DC motor directly to the Arduino, that's not a good idea. The Arduino can only provide very little current to external devices, and only tiny motors will be satisfied with that power. In virtually all real-life applications, we need to provide external power to the motor, and only signaling from the Arduino. To do this, I'm going to use a breakout board that contains the L298N motor driver bridge. This IC can provide high current to our motors, so we can use it in power-hungry applications. You can use this IC on its own. You need to provide supporting capacitors and diodes, etc. So I find it a lot more convenient to use a breakout board that contains the L298N, such as the one in this image. You can get these devices fully assembled and ready to use on eBay for a couple of dollars. Here's a schematic of the circuit we're going to build. I've noted on the image the name for each pin. We've got out 1 and out 2, which control the speed and direction of motor number 1, and out 3 and out 4 control motor number 2. As we're using DC motors, the higher the voltage differential between the pins in those two pairs, the faster the motor will spin. If you want to reverse the direction of spin of the motors, you can change the polarity of these pins. This is something that the L298N will do for you with the appropriate signal in the input pins. In 1 and in 3 control the direction of spin for motor 1 and motor 2 respectively. And finally, in 2 and in 4 control the speed of each motor. P9 receives 12 volts or higher from an external power source. In the schematic, I showed two 9-volt batteries in series to give us a total of 18 volts. Alternatively, you could use an external power supply, which is what I'm doing in these experiments. Finally, pin 10 is for ground, and it should be connected to one of Arduino's ground pins so that both the Arduino and the breakout board are grounded together. Okay, enough with the preliminary. Let's put this circuit together and also look at the sketch. So what we're going to do now is put together a circuit that's going to allow us to control these two DC motors through our Arduino. In between the Arduino and the DC motors, we're going to have this breakout board. It's a motor control breakout board that is based on the L298N integrated circuit. Explain how this works in a minute. Now let's have a look at the DC motor. That's how they typically look like. You provide power to these two pins, and depending on the polarity and the way that you connect these two pins to a battery or to a power supply, and the shaft spins in a particular direction. If you want to switch the spin direction, you just switch the voltage in these two pins. And in this particular toy, the DC motor provides power to a wheel through a shaft, so you can connect the wheel here, and then a little tractor track goes over that wheel to move the toy. So we've got a bunch of gears inside this box. So this is a gearbox. It takes a high rotational speed from the motor, and translates it into higher torque but lower rotational speed. And I've got another example of a geared DC motor with the gearbox exposed. So that's what it looks like on the inside. Right, so you can drive fairly big toys or other objects like that. I'm going to put these back together. And continue with all the connections. So secure the motor against its gearbox. Need to use this little plastic component to secure the motor. So it's tricky, so I'll try to use my Swiss Army knife to plug that in. Go. Right. Goes here. Close the motor compartment. Okay, that should be fine now, the way it is. So the next thing to show you is this motor driver breakout board. So you could assemble this yourself with a bit of soldering, but you'd need to have all these other components apart from the integrated circuit. So there's a couple of capacitors here just to provide especially startup power. There's diodes for back current protection. You don't have to worry about all that, of course, if you use the breakout board. So I got this for $2.5–3 on eBay. So what you have is that these two sets of 2 pins each are the ones that we connect directly to the motors. So just plug in one motor on one side and the other motor on the other side. And the Arduino controls the speed and rotational direction of the motors through these 4 pins. So there's in1, in2, in3 and in4. One set of 2 pins each for each one of the motors, and I'm going to show you how these work once we have a look at the sketch in a few minutes. Finally, because the Arduino cannot provide enough power to drive motors that are larger than the very little ones, this breakout board allows us to provide external power to the motors. So we've got a 12 volt and 5 volt connection here, plus the ground pin in the middle, and this IC can provide a few amperes of current, which means that we can drive DC motors or even stepper motors of quite a large size, with quite large torque. So we'll be using the 12 volt connection here with an external power supply. I'm going to start by connecting the 2 motors first. So I'm going to plug in the white jumper wire in here. And yellow wire for the first motor is in here. And on the other side, got the green and the white. Green goes here, and white. To loosen up a bit. Screw. Okay, and white goes here. Next, as far as power is concerned, I'm going to use external power supply, which I got from a cordless phone. This one's rated at 9 volts, 350 milliamps of power, so it's okay for what I want to do here. I've got the other end connected with a couple of jumper wires straight to the adapter of the power supply because I didn't want to cut it. I want to be able to use it again later. Of course, this is not a very portable solution, so if you wanted to build this for a toy car perhaps, or a remote control car, then you could use one of these. Power pack provides enough voltage, enough power for anything that moves. So I'm going to plug the red wire in the 12 volt outlet. This breakout board has got a voltage regulator, so as long as the power you're providing is above 6 or 7 volts, it will work. The regulator is going to adjust that voltage as needed. And also attaching a black jumper wire in the black wire that's coming out of the external power supply, because I need to connect that to the ground pin of the Arduino, so that way the Arduino and the breakout board can close a circuit so that the whole thing can work together. So I'm going to plug this into the Arduino in a minute to make sure that now the breakout board has power. So I'm going to plug the power supply into an outlet. Okay, so I've got a red LED lit up, so we have power. So the last thing to do is now to connect the controlling pins in 1 to 4 from the breakout board to the Arduino. And I've created this little hack. I found this adapter at another gadget I managed to ruin, and I connected extension leads to it, just making sure that the colors are maintained all the way through. So that way this is going to plug in easily in here. When I got this breakout board from eBay, it did not contain this adapter, so it was going to be very hard to attach the wires without causing shorts or other problems. So now I'm going to plug these 4 wires to pins 4, 5, 6 and 7 on the Arduino, which are PWM capable. So red is going to go to number 4. And yellow is going to go to number 5, so that goes in here. Then black is going to go to number 6, and white is going to go to number 7. Of course, because these don't really stay nicely on the Arduino side, I am going to use a bit of electrical tape to hold them down, secure them in place. Go. And don't forget to plug in the ground on the Arduino side, so that we've got a circuit between the Arduino and the breakout board. Alright, now everything is connected, so I'm going to plug in the Arduino into my computer. And I've already got a sketch, this sketch uploaded to the Arduino, so I'm going to start working immediately. So the thing to notice here is the direction of the rotation of the two shafts. So this one is moving that way. If you look at it up like this, is anti-clockwise, and the other one is going anti-clockwise as well, the way that we observe. Having a look at the sketch, I'm going to upload the default sketch, which sends a high and high value to M1 and M2, which are pins 4 and 7, and these two pins control the rotation direction of the two motors. Pins E1 and E2, which are number 5 and 6, control the speed. So let's upload the default. Let's see how the motors spin. Alright, so this is now moving clockwise, and it is moving anti-clockwise. If I want to change the direction of rotation, let's go for the M2 for example, I can switch that to low, so low signal, to M2, which is pin 7, and upload. Now you can see that this is also moving clockwise, while previously it was moving anti-clockwise. While the direction, rotation of direction for this didn't change, it's still high. So finally, the last thing to notice is that speed is controlled by using the PWM capability of, in this particular case, pin 5. So I've got a loop here, it's counting from 0 to 255. So obviously, the higher the value that we send to E1 and E2, the faster the motor will move. And that's how you can control one or two motors with a single breakout board using a popular motor control chip.